Hi, this is Tim, and I wanted to give a quick explanation of the triple shadow transit for January 2015. I'm doing this with simulated computer software. The software I am using is Starry Night Pro Plus 7, and you can see labels hanging in space for Jupiter and its moons as I animate this. There are over 60 moons of Jupiter. I think at last count we are up to 67 now, official count. They stumble on to others from time to time. And most of them are believed to be captured asteroids. But there are some particularly big ones that were discovered by Galileo back in the 1600s when he viewed Jupiter through his telescope. And those four biggest moons of Jupiter are called the Galilean moons, named for Galileo, who discovered them. Their names are, in order, Io, the closest, Europa, the second closest, Ganymede, the third closest, and Callisto is the farthest outermost moon of the four. Ganymede is the largest. It does not participate in the triple shadow transit event, but it is the largest of the four Galilean moons. It's the largest moon in the solar system, and it is so large that it is actually bigger than the planet Mercury. So with that, here we go with the animation is starting now, and you can see Callisto at the bottom of your screen. Io has also just showed up, and the shadow that you see on the surface of Jupiter right now is the shadow of Callisto. As Io is moving much faster, of course, it's the innermost of the four moons, so it moves the quickest. You're about to see its shadow appear on the screen as well on the surface of Jupiter, and there it is now. And those two shadows are actually going to merge. When that happens, Callisto actually sort of blacks out the light from Io, so you get a sort of an eclipse event that happens. And that would be happening now. Now, my simulation software does not darken out Io. And now you're going to see Io is actually going to cover up the spot of the shadow. Almost. It's not quite big enough to do it, but it passes directly through that shadow. And now you see Europa and all three at the same time. And now you see Io has gone off the far side. If I didn't mention it already, the simulation is actually running at 300 times normal clock speed. So the period of time, I'm in U.S. Eastern time, roughly I think it's 127 to 153. So it's a period of, it's about not quite a half hour. That you get to see all of this happen. And there are those other interesting events where the moons, eclipse each other that are kind of interesting to watch. We don't get to see an event like this again not visible from North America until the end of 2032. Now, that's not to say it doesn't happen again. It does, but we're just not in a favorable location to be able to witness the event happening. Obviously, if this happens and the Earth is on one side of the sun and Jupiter's on the other side of the sun, then we're not in a favorable position to witness that event. If it happens when we're on the same side of the sun as Jupiter, and you'd think we'd be able to see it, well, now you have to be on the right side of planet Earth. So if it's daytime where you live when this event happens, then that means you don't see Jupiter, you see the sun. But people who are on the nighttime side of the planet, they get to see it. So it won't be until 2032 when this happens again, and the Earth is in a favorable location, and North America is on the nighttime side of the Earth to be able to see it happen. So that's the explanation of the triple shadow transit event. Hope you've enjoyed it.